Good morning students, welcome to our next lecture of minimum spanning tree. In last lecture we have discussed about the introduction of spanning tree and then we studied basic properties of the spanning tree and the minimum spanning tree. As discussed, as I told you in last lecture, that for implementing minimum spanning tree we have two algorithms. First one was Kruskal's algorithm and the second algorithm was Prim's algorithm. So in today's lecture we will discuss about Kruskal's algorithm. Now let's first understand the basic definition of Kruskal's algorithm. Kruskal's algorithm is mainly used for a minimum cost spanning tree, and it builds that minimum cost spanning tree edge by edge. Edge by edge means by using the edges of the spanning tree, of the minimum spanning tree. Here minimum is mainly used to define the cost, the minimum cost that can be used to reach from source node to destination node. Okay, that's why we are using the word minimum. So what Kruskal's algorithm says, that Kruskal's algorithm is a minimum cost spanning tree in which a minimum cost spanning tree is built edge by edge. Okay, and then edges are mainly included in that tree, which is denoted by capital T, and the nodes are put in the increasing order of their cost. Increasing order of their cost means the nodes are considered in the increasing of their cost. So first node that will be considered will be of minimum cost, then the next node that we will consider will be the cost higher than the previous node. So for solving the Kruskal's algorithm we mainly use two steps. First step is determine an edge with minimum cost. What we will do, we will take a minimum spanning tree, and for this minimum spanning tree we will determine an edge with minimum cost. These are the costs. This is our spanning tree, and from this spanning tree we have to create a minimum spanning tree. So the first step of creating a minimum spanning tree is determine an edge with minimum cost. What we will do, we will determine an edge with minimum cost. Minimum cost means the weight, the cost which is given along with the edges. These cost and weight are mainly used to travel from one node to another, and to travel from one node to another we will always take the minimum cost. Okay, so our first step is determine an edge with minimum cost. So for traveling from node A to node B, C and D, we will determine the edges with minimum cost. And the second step says that deleting that edge from graph and add to tree. Now when we determine an edge with minimum cost, then we will delete that edge from the graph and insert that edge in the tree. So let us understand these two steps from the diagram and solve this numerical. Since this is our main spanning tree, from this spanning tree we have to create a minimum cost spanning tree. Minimum cost spanning tree means we have to create such a spanning tree that covers all the nodes with the minimum cost. So for creating a minimum spanning tree, first of all we will create a table which contains the edge and the weight of those edges. So from this first table we have edge AB, that means the edge that is going from A to B has weight 2 and the other edge has weight 3. Similarly for edge BC, that means the edges going from node B to C have weights 4 and 6 respectively. Similarly for edge BD, the cost of edge BD is 7 and CD edge cost is 2 and 4 again, and the last edges that are going from A to D are DA, that is, and they have cost 9 and 14 respectively. Now this was our first step of solving the spanning tree. From this first table, now we will create another table with the weight of all the edges in increasing order. That means we will write down the weight of different edges in increasing order. So this second table contains all the edges and their weight in increasing order. That means the weight, minimum weight comes first, then the weight following it are always increasing. So now we have created the table that contains the weight in increasing order. Our next step is we will create a skeleton of our spanning tree. We will create a skeleton of our spanning tree. As I have told you in our previous lecture, skeleton means the tree that contains only nodes, not the edges. So that's why we call it a skeleton that contains only nodes. Now we will construct a minimum spanning tree based on the table that we have created in step 2 with the increasing weight of the edges. These 4 are our nodes which we have taken from our main spanning tree. These 4 nodes should be connected with minimum number of edges as possible and minimum number of weight also. That means these 4 edges should be connected in minimum cost as possible. So what we will do, we will take first edge with minimum weight. First edge with minimum weight is AB. That is the edge AB with minimum weight 2. So we will connect our nodes A and B with an edge, and this edge has weight 2. Now we will look for another edge that will connect nodes either B or C or A or D. So our next edge with minimum weight is CD. The weight of edge CD is 2. So we will connect edge from node C to D, and it also has weight 2. Now we need one edge to connect these 4 nodes to make it a minimum spanning tree. We need only one edge, and that edge can be either from B to C or A to D. Since we are constructing a minimum spanning tree, so what we will do, we will take an edge with the minimum cost available. So we will look for the edge either from B to C or A to D with minimum cost. Since B to C edge has weight 4 here and A to D has weight 9 and 14. So 9 and 14 are greater than 4. So what we will do, we will take weight 4 and edge B to C for connecting our minimum spanning tree. The weight of edge that is connecting B to C is 4. So we get here a minimum spanning tree that is connected, that is properly connected, completely connected, and it is connected using 3 edges, that is n minus 1 edges. And here n means number of nodes. So we are using 3 edges to connect our minimum spanning tree. Now calculating the minimum cost of our spanning tree is, minimum spanning tree is 2 from A to B plus cost 4 from B to C plus cost 2 from C to D gives us the cost 8. So this is our minimum cost of this original spanning tree, and this is the minimum spanning tree. We can construct other minimum spanning trees also, but this tree created gives us the minimum cost. No other path will give us minimum cost less than 8. So this was our Kruskal's algorithm. I hope you understand. Thank you.